island of Hawaii was built by 5 huge volcanoes, the highest of which towers almost 1,000 feet above the ocean floor. Here is the story of how the island was formed. Kilauea is currently the most active and probably the youngest of the volcanoes. Many of its eruptions occur in its summit caldera, 4,000 feet above sea level. This eruption started in Kīlauea Iki, a pit crater separated from the summit caldera by a narrow ledge. This is a hypothetical cross-section of Kilauea, showing what geologists have learned about its structure. It consists of a great pile of lava flows built upon the ocean floor. Molten magma, which becomes the lava of the eruption, originates about 35 miles below the Pacific Ocean and gradually moves upward into the crust of the earth to accumulate within the volcanic pile beneath the summit caldera. In this greatly exaggerated sketch, we see how the pressure of this newly introduced magma inflates the summit area preceding the eruption. Magma breaks through first as a summit eruption in mid-November 1959, making a lava lake in the mile-long crater of Kilauea Iki. After this early phase of eruption stops in mid-December, more magma moves laterally along a rift zone, presumably connecting with underground pockets of molten material left from previous eruptions. It finally breaks through the surface as a flank eruption at Kapoho in mid-January. Some of these flows reach the ocean. This great drain of magma from beneath the summit area allows the volcano to deflate. And by mid-February, the ground surface subsides as much as 5 feet. The fountaining of lava ceases, and the eruptive cycle is over. For some time prior to the eruption, a seismograph nearby registered numerous small earthquakes. Then at 8:08 in the evening of November 14th, the earthquake ceased abruptly as the summit eruption started from a half-mile-long line of fissures halfway up the south wall of the 650-foot deep crater Kilauea Iki. Within an hour after the outbreak, cameras were set up about a mile away to obtain these photographs of lava fountains spurting to heights of 50 feet. They feed a number of braided lava streams that pour down more than 300 feet to the bottom of the crater, where they coalesce and begin to spread across the floor. The flat, 37-acre floor of the crater, formed by lava extruded in 1868, is rapidly covered by the new lava. Sparkles of light dancing over the lava are burning trees carried along by the flows. As they move across the floor, they break through their own cooler margins, forming lobes. During the next 2 hours, the fountains increased to 100 feet high along the entire half-mile line of fissures in the crater wall. These lavas contain less than 50% silica and cool to form what are called tholeite basalts. The hottest lava is bright yellow-orange. As its surface cools, it becomes dark red, although it's still very hot inside. By 10:30 p.m., fountain declines at the outermost vents, but they continue to glow, and many emit gases that burn with pale yellow-blue flames. Large bubbles of rising gas in the vents cause vigorous splashing of the lava over the edges. Before sunrise, the main fountain is 100 feet high and looms above trees that have been stripped by heavy masses of lava spatter falling through them. At sunrise, only 2 fountains remain. Lava from them flows down the narrow trough in the west end of the crater, cascades over a steep bank, and on into the deeper part of the crater to the left. the main fountain builds itself a small spatter rampart. Still later in the morning, the lava lake has spread to the forested slopes. During the extrusion of lava, seismographs in the vicinity record an unusual type of motion of the ground called harmonic tremor. Scientists of the Geological Survey's Hawaiian Volcano Observatory prepare to collect gas and lava samples at the base of the fountain, now only 200 feet away. Sulfur dioxide fumes and intense heat radiation make such sampling difficult, but these samples aid in interpreting the origin of the magma and the mechanism of the eruption. They may help also in understanding the origin of the atmosphere in the oceans, as vast quantities of such gases have been given off by countless volcanoes over the long span of geologic time. Lava rivers flow down the steep slope, with one on the right flowing along the former Kīlauea Iki trail. Through the second day, more and more lava pours from the one remaining fountain. Sudden fluctuations in the output often cause the entire cascade leading into the deep part of the crater to be awash with lava as it flows down the slope and under the crust in the ever-deepening lake. On a fairly steep slope, the lava forms vigorous rapids over irregularities in the channel, breaking apart floating pieces of cooler crust. Although flowing like water, this lava actually is a highly viscous fluid. Here, the lava plunges over a steep cliff, forming a lava falls. On a smooth slope, the lava river appears as a bright, incandescent ribbon flowing at speeds up to 20 miles an hour. The flow is fastest in narrow channels, where the channel widens, pooling of lava occurs. The river of lava winds down the valley through natural levees of its own making. It splits and recombines around barriers, much like water in braided river courses. As the stream pours into the rising lava lake, it flows under the chilled but still flexible crust, floating it upwards. The fountain continued through the night, sometimes suddenly showering new portions of the crater slopes. Through the first 6 days of activity, the fountain has continued to grow to more than 10 times the height of Niagara Falls. It forms very strong air currents and more pumice and cinder, which the prevailing trade winds blow to the lee of the vent, building up a large pumice and cinder cone on the crater rim. By the end of the eruption, the top of this cone will be 400 feet above the level of the vent. Viewed from the southwest during a temporary lull, the cone obscures the eruption, and only fume clouds can be seen in the background. Seen from the air at late sunset, the massive orange 800-foot fountain sends hundreds of thousands of cubic yards of lava per hour into the rapidly filling lake. Here, just prior to the end of the first phase of the Kilauea Iki eruption, the fountain shoots 1,000 feet above the surface of the lake. Although this appears to be an exceedingly violent eruption, geologists actually consider Kilauea to be one of the least violent active volcanoes on Earth, and hence most suitable for close study. Obstructions in the vent may suddenly divert the jet, causing devastation of large areas surrounding it. The week-long first phase ended abruptly when the level of the lava in the lake reached the vent, and about 40 million cubic yards of lava filled the 140-acre lake to a depth of 335 feet. Following a 4-day period of quiet, fountaining resumed from a slightly higher elevation in the former vent area. Some of the 16 subsequent eruptive phases, which ranged in duration from 2 to 32 hours, started very abruptly. The fountain in this phase rose from 0 to 700 feet in a few seconds. An eruption brings many visitors to the park where they view nature's spectacle from a safe distance. This is necessary as changes in the direction of the jet take place suddenly. Here, the lake has covered the vent, and cooler material is carried as high as 1,200 feet. Many of the 17 phases of this eruption started with a massive bubbling in the lake over the vent. This spasmodic, geyser-like sequence of eruptions, separated by periods of quiescence and backflow, had never before been observed in Hawaii. After massive boiling and bubbling in the vent area, the activity would gradually increase to form a strong fountain playing hour after hour. Although this appears to be shown here in slow motion, it is not. The lava is actually falling hundreds of feet directly into the fluid lava lake at the base of the fountain. This fallout and disturbances at the vent form waves that spread out over the lake's surface. Thin jets of lava rise up 30 feet above the surface as heavy fluid masses of spatter the size of bathtubs hit the lake. In the distance, the larger waves wash up on the crater wall, much like the ocean surf on a beach. A brilliant 500-foot fountain with temperatures up to 1,200 degrees centigrade reflects from the glassy surface of the 400-foot deep lake. The fountaining action is caused by the effervescence of dissolved gases in the lava, released when it approaches the surface. This fountain is spurting from 1 to 2 million cubic yards of lava per hour. Changes in the vent shape and in the violent release of gas cause variations from the almost explosive spraying of lava seen here to jet-like fountaining as high as 1,900 feet during later phases of the eruption, the highest fountaining ever recorded in Hawaii. The solid crust of the lava lake continually breaks and huge rafts plunge beneath the molten lake. This continuous foundering and reforming of the crust occurs during both the filling and the draining of the lake. At night, the phenomenon shows well the rapid cooling of the exposed lava surface. At the edges of the lake, trees and forest litter were often buried by lava. For some time, individual tree trunks give off superheated organic gases that burst into bright yellow flames as they explode from the surface of the lake. The more violent fountaining rapidly builds up the cinder cone behind the vent. From 2 miles away at the Hawaiian Volcano Observatory, a large steam and fume cloud is seen forming from the fountain. all of the eruptive phases ended abruptly with the lake level above the vent. Here the fountain has just died and an avalanche of hot cinder tumbles down the face of the cone into the lake. After each fountaining phase, some of the lava lake drains back down the vent. Often the rate of backflow reaches 2 million cubic yards per hour, or more than twice the average rate of extrusion. The returning stream of lava forms a slowly moving whirlpool, perhaps 50 feet across, directly over the vent. As much as 10 million cubic yards of lava will go down the vent after each eruptive phase. At night, this backflow of lava into the vent is particularly spectacular, plunging into the gaping maw of the vent, carrying with it great rafts of blackened crust. Large slides tumble down the face of the pumice cone, exposing its incandescent interior. These too are carried down by the lava, flowing back into the vent, presumably to be melted again. Immediately after the eruption ceased on December 19th, a yellowish-white cap was formed by acid gases from the hot interior. The tremendous fountains produced great quantities of pumice that fell in a blanket extending many miles downwind. Only a lonely, rather macabre road sign and the stark skeletons of trees remain in the devastated area behind the cone. The lava lake will take many years to cool. Although nearly 50 million cubic yards of lava lay in this lake, the summit of Kilauea continued to swell until early January 1960, when magma evidently moved into the east rift zone of the volcano as earthquakes began to emanate from an area about 24 miles east of the summit. The precise location was determined by means of this portable truck-mounted seismograph. Unlike Kīlauea Iki, this is a populated area with farming villages and fairly intensive cultivation. By January 13, the earthquake activity shifted further east along the rift zone, and a half-mile wide strip of land through the village of Kapoho slowly began to subside. The village was quickly evacuated, and by mid-afternoon, the maximum subsidence of the strip, or graben, was about 4 feet. Here, the fault scarp along the south side of the graben can be seen extending through the village. At 7:30 in the evening, the flank eruption started. Through the center of the subsided block of ground, a series of lava fountains form a spectacular curtain of fire 3,500 feet long. Lava fountains up to 100 feet high play along the entire rift for almost 4 hours in an area about 60 feet above sea level and only 2 miles from the ocean. A rather fluid lava flow advances rapidly through a sugarcane field north of the village. As the flow moves forward, pieces of the cool crust break and slide down the front to be overridden by the fluid interior. The outermost vents die out as the molten lava congeals in the feeding cracks beneath to form basaltic dikes. The next morning, we see Geological Survey scientists making measurements of the lava fountains. The temperatures, measured at night with an optical pyrometer, were generally lower than those measured during the summit eruption. During the night, and on the morning of the second day, brackish groundwater gained access to the underground lava conduits, and great convoluting clouds of dirty ash-laden steam blast from the vent. Vents erupting lava are side by side with roaring jets of steam, and some vents alternate between blasting out pure white steam and molten lava. Downwind, the land is being covered with a layer of salty ash. From the air, the steam blasts present a spectacular display. The river of lava, here 300 feet wide, pours from the erupting vents and slowly flows down the graben toward the ocean 2 miles away. Two days later, the flow reaches the sea, and a large steam cloud marks its entry into the water. 2,500 acres of land, including all you see here, some of it fertile and highly cultivated with papaya, sugarcane, coffee, and orchids, will eventually be buried under lava from this eruption. A curtain of steam hides the massive flow front as it pours into the ocean. Jets of black sand formed by the rapid disintegration of the hot lava in the cold water spew out of the steaming veil. Fragments of lava continually roll off the front of this blocky or lava flow as it builds up new land into the sea. Minor explosions send small projectiles into the air. After 1 week of eruption, the graben was filled with lava and flows began to spread laterally over the flat countryside. Here, an flow advances through a scrubby forest growth. These blocky flows are of the same chemical composition as the smooth or ropey-surfaced Pohoihoi flows, but differ from them in that they're more viscous and form a very slow-moving, pasty mass. When cool, much of this flow will consist of clinkery rubble rather than solid rock. This 15-foot flow pushes relentlessly through a papaya grove on the immediate outskirts of the village of Kapoho. The fountaining vent is in the background. Near the vent, falling cinder and pumice have completely stripped the leaves from the papaya trees. The schoolhouse and other buildings in the village of Kapoho are slowly consumed by lava. The main lava river occasionally breaks through its natural levees. At dawn, a string of vents form orange fountains against a gray sky. During this eruption, there was deflation or subsidence at the summit of Kilauea, 30 miles to the west, about equal to the total volume of the lava extruded, indicating a close underground connection between the summit and flank. Other parts of the string eventually die, leaving only a single vent, feeding 7 million cubic yards of lava per day to the advancing flow fronts. Many visitors viewed this early stage of the eruption. Later stages were even more dramatic, where a single huge fountain over 3 times the height of the Washington Monument played hour after hour. From the air, the fountaining, up to 1,700 feet high, presents a spectacular sight indeed. Flank eruptions are generally of larger volume than summit eruptions. This one yielded 160 million cubic yards of lava and built up a massive cinder and pumice cone. By February 8, only a gas-charged cinder jet roars from the dying vent. And by February 18th, the eruption was over. Where formerly there were farms, now all is a barren waste, covered with tens or hundreds of feet of lava flows and volcanic debris. Some 500 acres of new land was made by the flows, added to Hawaii, where formerly there was only ocean. But the barren land is not lost. In a few hundred years, the rough lava flows will be covered with vegetation. And here, only 1 year after the eruption, we see a grove of weed-like papaya trees, planted as seeds 10 months ago in the new pumice. The island recovers quickly, for here in the seemingly barren expanse of black pumice that fell just 1 year before, we see row upon row of cultivated orchids. Thus has the island been built up from a countless series of volcanic eruptions over tens of millions of years.